Okay, in this video lesson we're going to talk about solving for angles, but more importantly than just solving for the numbers, we're going to be talking about the reasons why the angles are what they are. Just a quick example, you'll see these three here. It probably would not take you very long to figure out what the value of x, what the value of y, and what the value of z would be on some simple calculations. But what we're going to talk about in this chart that we're going to fill out is why these angles are what they are, and if you were to explain what the value of the angles, how would you explain it? So that's going to take us to our next. Okay, so we're going to fill out this chart. If you notice on the left side here, we have some examples of some situations with angles, and on the right side what we're going to do is just fill out the chart and write down the reasoning for why the relationships that you see on the left are true. The first one, you'll notice that they're telling us that angle A is going to equal to angle B. To justify that, just for example, if angle A was 30, so would angle B. To justify that, we're basically going to just be identifying what type of angles they are. In this case, they're called vertical angles. So to justify it, or to provide a reason for why these angles are both 30 degrees, we'll simply say that vertical angles are congruent. And again, that's our reason to justify why these two angles are equal. The congruent sign that we'll be using throughout this looks like that. This next one we're actually going to skip here. For this third one, and third and fourth one, what you'll notice is that both of them are talking about angles that are adding up to 180 degrees. For that we use the term supplementary. There's a little bit of difference in the two of them. In this first one, they're talking about two angles, A and B, that add up to 180. Well, when I have two angles, we can call them a pair of angles, and if they are on a straight line, as they are here, we can call them a linear pair. Linear meaning line, pair meaning two. So here we will say that linear pairs are supplementary. So anytime you use this supplementary concept, your reason would be because they're linear pairs and that they're supplementary. In this particular case, same idea in this fourth one, but we just have multiple angles. Instead of just a pair of angles, we have, in this case, four. So we can say, in general, that angles that lie on a straight line are supplementary. Okay. If we move on to the next slide. Alright, so we'll see at the top here that we have a situation where we have angles adding up to 360 degrees. If you'll notice, all three of these angles that they're talking about are all around this point B. So if we ever have a situation where we need to solve for angles around a single point, we're going to use the concept that they add up to 360. So we will write that angles around a point add to 360 degrees. The next three here have to do with triangles. We're actually not going to be doing that one, so we'll skip that one. But the second one on this slide here is showing us that if I take all three angles of a triangle and add them up, the sum of those angles is going to be 180 degrees. It's very simple. Everybody knows it, but we use it to help solve problems. So we will jot that down, that the angles of a triangle add to 180 degrees. This last one down here at the bottom, very important, got to introduce a few terms that you may or may not be familiar with. We're talking about, in this case, angle BCD. That is right here. That's called an exterior angle. Okay, EXT meaning exterior angle. The other angles that we're talking about here, angle A and angle B, those are called non-adjacent angles. Alright, and what this little theorem is showing us here is that if you add the two non-adjacent angles, it will equal the exterior. Just as a quick example, if angle A was 70 and angle B was 50 degrees, then the exterior angle would have to be 120 degrees. So we will jot that down. and we'll say that the sum of the non-adjacent angles is equal to the exterior angle. All right, and we'll be using that a lot as well. In these first two up at the top here, we see two triangles. In this first one up here, we see that they're marking the two bottom angles, and these markings are trying to tell us that those angles are equal. Well, if I have a triangle and I have two angles that are equal, that's called an isosceles triangle. It's definitely going to help us solve for angles and help us in problems. So in this case, if we're going to use this idea of an isosceles triangle, we will say that in an isosceles triangle, base angles are congruent. Okay? In this next triangle, you'll notice that all three angles are shown as congruent. In that case, we have what's called an equilateral triangle. So if we ever have a problem dealing with an equilateral triangle or using the angles of an equilateral triangle, we can state that in an equilateral triangle, all angles are congruent. These three we're going to take care of in class. Okay, so we don't have to worry about those right now. Here, this is for you to complete. In this, for these problems here, I want you to find the measure of each of these angles. So find A, B, C, D, and E. That's right here. That shouldn't be that hard, but I do also want you to provide a reason for why the angles are what they are, and the reasons you're going to be getting from the chart we just filled out. So if you use linear pairs, if you use vertical angles, please jot down that reason to justify the angle measure. All right.